All right, so we have arrived at 8.4 when we're going to learn about trigonometry. So trigonometry is basically the measurement of triangles. So this word part, metry, has to do with measurement. So geometry is measurement of the earth. Metric system is a measurement system. So when you see meter like that, it generally means measurement of things. And trigon would be a polygon with three sides. So that would be another word for a triangle. So we're looking at measurements of triangles, specifically here right triangles. So we've seen there are some special predictable relationships within right triangles with the Pythagorean theorem and with special right triangles. So what we're going to see here is that with a right triangle, we can get a lot of information with very little. So we found A, B, and C with special relationships in special right triangles. But we actually, if we know a right triangle and one angle measure, we can find all the sides given any one of them. It doesn't have to be one of those special right triangles. So there's three fundamental functions within trig that we're going to learn about in geometry. There are some other things that you'll learn about in later math, but these are kind of the foundation: sine, cosine, and tangent. These are super important. Like I've said before, this is the probably biggest thing you take out of geometry into later math, so it is important that we understand it. Your understanding of it will also evolve throughout math. So right now we're talking just about right triangles, but these have a lot to do with circles as well. So you're going to see these a lot. Okay, so sine, we abbreviate SIN. We take off the E, so not much of an abbreviation. But we have a three-letter, basically, shorthand for each of these. So sine, we pronounce this as sine, even though it looks like sin. Cosine, we pronounce as cos. So sine, cos, and tan. So those are our shorthand and the way people typically say them. So sine, cosine, and tangent are relationships between sides of the right triangle. So sine is the ratio of the leg opposite the angle that we're focused on to the hypotenuse. So if we are talking about this triangle here, we have this angle A and this angle B. And each of them has a different perspective on this triangle. So think about somebody standing over here is seeing something different than somebody standing over here. They have different perspectives. So as far as A is concerned, the opposite leg is down here, A. So it would be A over, or 2, because it's a ratio, C. So it's the opposite side from our angle relative to the hypotenuse. So A to C, or you could write it A to C, although writing it as a fraction makes a lot more sense because we're going to do math with it. But then if we change our perspective and come and stand over at B, so we're over here now, and we look that way, our opposite side is now this one. So the sine of angle B is little b over C. So I hate that they used A and B here, but whatever. So as far as A and B angles are concerned, they think the sine is different. So whenever we talk about sine of an angle, we have to specify what angle we're talking about. So generally when you use this function, you give it an angle measure. So you'll put like sine of 40 degrees, and that will give you a ratio of a number over a number, which we typically use a calculator and express that as a decimal. So sine of, as far as A is concerned, say this was 40 degrees, he would say that sine 40 is this, and then B would be over here looking at sine of 50 degrees is B over C. So as you might imagine, the sine, we'll get to that in a minute. So cosine. Cosine is very similar, except that each angle is going to look at its adjacent side. So adjacent means the one right next to it, rather than the opposite side. So A says the cosine would be B over C. and B thinks the cosine is A over C. So notice that those are exactly backwards. So what A sees as sine, B sees as cosine. So they're basically flipped. So you could say A is seeing the sine of 40, B is seeing the cosine of 50, and both of those are going to be the same thing. They're both going to be A over C. So sine 40 and cos 50 are the same. Tangent is different. It relates the two legs and leaves the hypotenuse out of it. So from A, our tangent looks at the opposite side, A, and divides it by the adjacent side, B. So it's the ratio of A to B, and it would be like that. And for B, since it sees A as adjacent and B as opposite, it's going to be B to A. So the tangents of 40 and 50 are reciprocals of each other. So sine and cosine are basically equal when the angles are complementary, and tangent is tangent of an angle and its complementary angle are going to be complementary. So basically the tangent of 40 is the same as 1 over the tangent of 50 degrees, kind of like that. So sine 40, we'll say equals cos 50. And we'll practice with this and get used to how the numbers work. I just kind of want to introduce it here because we see here how the letters relate. So seeing that sine and cosine can be found from different corners but get the same result, I think is really important to understand. And the fact that the tangent is reversed too. So typically, this big remember here is used with an acronym for trigonometry that's been used for forever. So SOHCAHTOA is the mnemonic that people use to remember trigonometry. And it's kind of like how we use PEMDAS for order of operations, right? You've been seeing that forever. I believe that they're trying to get away from that in lower math for some reason, that they're trying to not use that acronym, but we're all familiar with it. This is another one. SOHCAHTOA is like the basis of understanding and remembering these trig relationships. So within these three parts, SO stands for sine equals opposite over hypotenuse. Cosine, that's the C, is relating adjacent over hypotenuse. And tangent is relating opposite over adjacent. So if you can remember that, and remember that basically we're just dividing each of these. So the first letter of each triple is the name of the function, and then the other two are the ratio, O to A or A to H or O to H. So that's really it. That's the fundamental stuff of like understanding what trig is. Now we want to see how we're actually going to use it to like solve some things. So step one is just to identify what are sine, cosine, and tangent from like a picture where we have all the information. Step two, or maybe three, is going to be finding missing information using these functions. So first we want to understand what they're telling us so that we can then understand how to use them as tools. So sine of A, so our focal angle is here, and we're looking for, I'll write SOHCAHTOA over here. So sine, we want to find the opposite angle and divide by the hypotenuse. So as far as A is concerned, opposite is 5, and hypotenuse doesn't matter which one we're at, right? Hypotenuse is 13. So this is H. I don't really want to label O and A because we're going to have different perspectives in these different problems. But I'll label H because this is definitely H. So 5/13 is going to be the sine from A. Cosine A will be 12/13 because we're doing the adjacent side divided by the hypotenuse. So 12 over 13. Remember, adjacent is the one that's helping form that angle. Opposite is the one that's the side that doesn't touch that angle. Tangent of A, we do O divided by A, so that's 5 over 12. Now we're going to look and go over to the perspective of C and redo all of that. But we know there's relationships between these. For example, we know that tangent should be the reciprocal of what it was here. And we know these two numbers should just be swapped here. But let's make sure they are. So sine of C, opposite over hypotenuse, we do 12 over 13. And yeah, that's the same as the cosine of A was. Then from C, the cosine is going to be the adjacent side 5 divided by the hypotenuse 13. And the tangent will be the opposite side 12 divided by the adjacent side 5. So something else that we want to observe here, but as we go forward, is that sine and cosine have a strict limitation of being between 0 and 1 because we're dividing one of the legs over the hypotenuse, and we know the hypotenuse must be longer than the legs. So the limitations, or you could think of it as the min and max, so basically sine is always going, so sine of, I'm going to put beta because that's just a random angle, is going to be greater than, in triangles greater than, but I'm going to put greater than or equal to 0 and less than or equal to 1. So that's basically the range. No matter what angle we put in here, the range has a limitation of 0 to 1. Now, since we're talking about right triangles, we can never actually reach 1 because that would mean the leg and hypotenuse are equal, and we can never reach 0 because that would mean the leg length is 0. But sine can go from 0 to 1. We just can't do it with these triangles. Cosine has the exact same limitation because, again, we're dividing a leg over a hypotenuse, so it has to be between 0 and 1. Tangent, on the other hand, we saw 5 over 12, but then the reciprocal was 12 over 5. So tangent does not have that limitation that sine and cosine have as far as its range. Yeah, so let's go on. I just wanted to throw that in there. I think it's an important thing for you to kind of get used to. So these two are going to be the same. You're going to go, the only difference here is that you may be able to simplify, and you may need to find a missing side using Pythagorean theorem or special right triangles or Pythagorean triples, any of that stuff. So I'll let you work those two. Let's look at the next page, and we're going to solve for a missing side using trig. So that's really where we get value out of it, is now that we kind of understand what we're doing with these functions, we want to actually utilize them. So this one, we want to find x. We know the angle 28. So what we want to do is figure out, as far as this 28-degree angle is concerned, what is this? Is it A, O, or H? So since I have to go across to it, this is my opposite side, and this is my hypotenuse that's labeled. So since I have O and H, the function I need, I'll write my thing here again. The thing I need to be using is the sine function. So when I have O and H, I use sine. So I'm going to put sine of 28 degrees equals, and then we're going to put O divided by H because that's the way the ratio goes. So x over 19. So here's where we're going to begin using calculators because we kind of need to. Because sine of 28 is some terrible fraction, like terrible irrational. I guess it's rational, but it's a terrible fraction that we don't want to deal with or don't know what it is just off the top of our heads because it's not one of our kind of special numbers like the 30, 60, 90 or 45, 45, 90. So let's get a calculator, and I have trig functions here. So we want to clear this. Hold on one sec. Okay, I don't really like that Windows calculator, so I'm going to switch to Desmos. It's a way better calculator. So notice the note here that said make sure your calculator is in degree mode. So depends on what calculator you're using. On the TIs that we have in class, it'll say DEG up at the top. On Desmos, it'll say DEG right here. If you click it, the other option, well, there's usually two, but on Desmos we just have rad. So rad is short for radians, which is a different way of measuring angles. And when you get to pre-calc, that's pretty much going to become the normal way that you measure angles. You're not going to use degrees anymore. Degrees are kind of a lower level way of understanding angles. Radians are higher level. They're no different. Radians is still just kind of a unit of measuring angles, but it has pi in it, and I guess that's scary, so we don't bring that in at this level in geometry. So we're going to be in degree mode where we see the DEG, and we're going to need to solve this for x. So I'm going to multiply both sides by 19, and in my calculator I'm going to put 19 and then sine of 28, which, remember, this 28 is understood as degrees. It tells us that that other side is 8.92. And we're approximating. It says round to the nearest tenth. I'd prefer hundredths personally, but 8.9 or 8.92 would work here. Now, watch what happens if I switch from degrees to radians. So if I switch degrees to radians, my answer is now 5.15, which is completely wrong. That's not the right answer, because 28 in radians would be whatever 28 times pi over 180 is. So it's a different unit, kind of like if you are intending to measure something in feet and you put in a number of meters, that's going to be a really bad thing that you did. So same thing here, we want to make sure our units are right and it's on degrees. So 8.9 is going to be our missing side here. And if we wanted to find the other one, it would be pretty simple. We could just go and switch this sine to cosine. So our other side is going to be 16.8. So that makes sense, right? 8.9 and 16.8 are both smaller than 19, so that seems reasonable that we could have that as a hypotenuse. If we actually squared those out and did Pythagorean theorem, then it would turn out to be right. Okay, so next one, we have a angle of 41. So we know we're using that angle, and we from there know the opposite side and the adjacent side. We do not know anything about the hypotenuse, so we're not going to use a function that relies on it. We're going to be using the tangent function. So tan is relating the two legs, and we're going to use our calculator, and we're going to do, I guess I should write it on the paper first, shouldn't I? So tan 41 degrees equals x over 32. So just like before, I'm going to multiply this 32 over to the other side. And we're going to use the calculator to find 32 tangent of 41 degrees. We find 27.8. So hard to tell if that's reasonable because the two legs don't really have any kind of relationship. But we're going to go with that. So 27.8 because the calculator says so. So the rest of these are going to work the same way. You're going to be finding a missing measurement. And let's look at a word problem. We don't do enough word problems. So this one is about Jake. It says Jake leaned a 12-foot ladder against his house. So we're going to put his house right here. And then we're going to put a ladder leaning against it. The ladder itself is 12 feet in length, so that's our hypotenuse. The angle formed by the ladder and the ground is 68. So my ground is down here. This is going to be 68. And we assume that his house has vertical walls and that this is a right angle to the ground. If not, he's got a messed up house. So we have 68 degrees. We have the hypotenuse is 12. The question is, what do we want to find? We want to know how far from the base of the house is the ladder. So that's down here is x. So as far as 68 is concerned, that's our adjacent side. So relating H and A, SOHCAHTOA, is cosine, and we're going to divide adjacent over hypotenuse. So cosine of 68 degrees equals x over 12, and as usual, since the 12 is on bottom, we multiply it to the other side, and we're going to check 12 cos 68. 12 cosine 68. So we have 4.5. So he put it 4.5 away, and remember to put units. Since we're given feet for our units of measurement, we're going to use that in our answer. So yeah, that finishes how to do sine, cosine, and tangent and use them to solve things. And then we'll need to talk about the inverse functions in the next lesson. But you have plenty to practice on this. It's a very important thing that we're practicing this. We really need to understand this one and be able to do it in our sleep.